Students, in this video we are going to solve one of the model question paper for Karnataka CET exam, and the subject is chemistry. So chemistry Karnataka CET model question paper we are going to solve. It is going to helpful for the coming NEET exam also. Let us solve the first question. The first question belongs to haloalkanes and haloarenes. We need to find out the incorrect statement regarding chirality. So the first statement, the product obtained by SN2 reaction having chirality at the reactive site shows inversion in the configuration. So in SN2 reaction, primary alkyl halides undergo nucleophilic substitution reaction. So this is the reactive site. So after nucleophilic substitution, we will get nucleophile opposite in the configuration compared to the haloalkanes. So as you can see, halogen is at right side, and the here in the product, the nucleophile is at left side. So this first statement is the correct statement, where we can find in SN2 reaction, we will find inversion in the configuration. Let us go to the second statement. Enantiomers are superimposable mirror images. So this is a wrong statement, because enantiomer shows non-superimposable mirror images. So enantiomers are non-superimposable. So option 2 is the right answer for this question. Let us go to the second question. So in this question, we have a Grignard reagent, and it reacts with dry ice. Dry ice means solid carbon dioxide in the presence of dry ether. When Grignard reagent RMgX, when it reacts with carbon dioxide, we will get one intermediate Y. The intermediate Y is RCOOMgX. So this is Y, and this on hydrolysis gives carboxylic acid. So here answer, we need to find out Y. The Y is RCOOMgX. This is the intermediate for this reaction. Let us go to the next question. In 1 molal solution, molality is 1, that contains 0.5 moles of solute. So solute is 0.5 moles. So we need to find out the amount of solvent. So in the formula, when we substitute these values, so molality is 1, number of moles of solute is 0.5. So weight of the solvent, when we calculate, it will be 500 grams. So option 1 is the right answer for this question. Let us match list 1 hydrides with their nature. Magnesium hydride, of course, it is ionic, and hydrogen fluoride is electron rich hydride. So we have to find out A matches with 4 and D matches with 3. So in the given option, in option 4, we can find out the right answer, where in option 4, according to the option 4, what we can find is, so magnesium hydride is ionic, GeH4 is electron precise, B2H6 is electron deficient because it has less electrons than octet electronic configuration, and HF is electron rich hydride. In the next question, we have two statements. Statement 1, the boiling point of aldehydes and ketones are higher than hydrocarbons because of dipole-dipole interaction. So this statement is right. Compared to hydrocarbons, in aldehydes and ketones, we can find more boiling point because of weak interaction, that is dipole-dipole interaction, that we cannot find in hydrocarbons. So let us go to the statement 2. The boiling point of aldehydes and ketones are lower than alcohols. The boiling point of aldehydes and ketones lower than alcohol, because in alcohol we can find hydrogen bonding, whereas in aldehydes and ketones, dipole-dipole interactions. So compared to dipole-dipole interaction, hydrogen bonds are stronger. That's why alcohols have higher boiling point and aldehyde ketones have lower boiling point. So in this case, both the statements are correct. Statement 1 and statement 2 both are correct. Let us move to the next question. As you can see here, alcohols have higher boiling point because they have strong hydrogen bonding. Aldehyde ketones have weaker dipole-dipole interaction. As hydrocarbons, that is alkanes, are non-polar, they cannot find such type of interaction. So we have one more matching question here. Cyanohydrin forms when carbonyl compounds on reacting with HCN, hydrogen cyanide, cyanohydrins are going to form. And acetal forms when carbonyl compound reacts with alcohol. And Skiff's base means carbon-nitrogen double bond forms when carbonyl compound reacts with primary amine, and oxime forms when carbonyl compound reacts with hydroxyl amine. So here option 3 is right answer. Option 3 is right answer, where cyanohydrin forms when aldehydes or ketone reacts with HCN, and acetal forms when carbonyl compound reacts with alcohol. Skiff's base forms when carbonyl compound reacts with primary amine, and oxime forms when carbonyl compound reacts with hydroxyl amine. So here is the reaction we can find. You can see here reactions. So carbonyl compound on reacting with hydrogen cyanide, cyanohydrin will form. Carbonyl compounds on reacting with alcohol, acetal will form. And with primary amine, Skiff's base, and with hydroxyamine, oxime is going to form. So this is the reaction. So let us go to the next question. So 61 question we are going to see here. The boiling point of the following hydrides of group 16 elements increases in the order. So this is the order of boiling point. So this statement is wrong because among the hydrides of group 16, water has more boiling point compared to the hydrides of sulfur, selenium and tellurium. Because in water we can find hydrogen bond that is not found in the other hydrides. So due to the presence of hydrogen bonding between water molecule has higher boiling point compared to the other hydrides. Let us go to the statement 2. The boiling point of these hydrides increases with the molar mass. So this is true in case of these three hydrides, sulfur, selenium and tellurium. Boiling point increases with the increasing molar mass, but is not true for water. So in these two statements, both the statements are incorrect. So statement 1 and statement 2 both are incorrect because water has higher boiling point compared to the other hydrides. Let us go to the next question from coordination compound, the IUPAC name of this complex. So in this complex you can find two ligands, aqua, water and cyanide. Both are combined with central metal silver. So this is di-aqua silver 1 and di-cyanido argentate 1. So option 3 is the right answer for this question. In the next question, which of the following is suitable method for the synthesis of chlorobenzene? So chlorobenzene can be prepared commercially by treating benzene with chlorine in the presence of FeCl3. So benzene on treating with chlorine in the presence of FeCl3, this is one of the commercial method to prepare chlorobenzene, because chlorine on reacting with catalyst FeCl3, it is going to form electrophile. It is going to form one electrophile, and that electrophile attacks the benzene ring to produce chlorobenzene by replacing one of the hydrogen atom. So electrophile reacts with benzene to form chlorobenzene, and it is one of the best commercial method to produce chlorobenzene. Let us move to the next question here. Assertion and reason question. Assertion A is ICl is more reactive than iodine. Of course, it is an interhalogen compound, so ICl is more reactive than iodine. Then reason, ICl bond, iodine chlorine bond is weaker than iodine bond. So iodine chlorine bond is longer and weaker. It can be break down easily. So in this case, assertion as well as reason both are correct. So both assertion A and reason are correct, and reason is the correct explanation for the assertion. In the next question, the IUPAC name of the element with atomic number 119, very easy. 1 means un, and 9 means innium. Innium. Option 4 is the right answer for this question. Let us move to the next question. At 298 Kelvin. At 298 Kelvin, the standard electrode potential of copper, zinc, iron and silver has been given. So you should remember electrochemical series. So in the electrochemical series, among the given 4 metals, zinc is at the top, then afterwards iron will come, then below iron we can find copper, and then we can find silver among the given metals. So here what we can suggest is the metal which is at the topmost position is more reactive. It is more reactive, and the metal with more reactive will be having low standard reduction potential. You can see in the question itself, zinc has low standard reduction potential among the given option, and silver is at the bottom of the electrochemical series. It is less reactive, and it is having high standard reduction potential of 0.80 volt. So based on this we can conclude that the metal which is at higher position can able to displace the metals of lower position in their salt solution. So we need to find out, in the question we need to find out on the basis of standard electrode potential, predict which of the following reaction cannot occur among the 4 reactions which cannot occur. So first reaction we can see, copper sulfate on reacting with iron produce iron sulfate. So as we know, iron is more reactive than copper, so iron can displace copper. This can possible. Second reaction, between ferrous sulfate and zinc, among zinc and iron, zinc is more reactive, so zinc can easily displace iron. This also can possible. In the third reaction, copper sulfate and silver. So silver is less reactive because it is having more reduction potential. So silver cannot displace copper from copper sulfate. So this reaction not possible. Fourth also can possible because zinc is more reactive than copper, so it can displace. So third reaction, the reaction between copper sulfate and silver cannot possible. Let us move to the next question. Which compound among the following is not aromatic? So you know in 11th CBSE hydrocarbons chapter we have learned if you want to call any compound as aromatic, it should follow Huckel's rule. According to Huckel's rule, it must have 4n plus 2 pi electrons. First possibility. Second, it should have planar structure. Planar means it must have sp2 hybridization. And one more thing is we need to find out alternate double bond, single bond, double bond, single bond. First case. And second case, either double bond, single bond, carbocation, single bond, double bond. This should be there at least, or double bond, single bond, lone pair of electron, single bond, double bond. It must be there. This should follow if you want to call anything as aromatic. Let us see one by one. So in the first case, you can see in this case you can find alternate double bond, single bond, double bond, single bond, carbocation, positive charge means carbocation also sp2 hybridized. All the carbon atoms are sp2 hybridized and they are planar and they can follow Huckel's rule because they have 6 pi electrons. So this is aromatic. First one is aromatic. Let us go to the second one. Second option. In the second option also you can find 2 pi electrons. 2 pi electrons, double bond is there, means sp2 hybridized, and carbocation also sp2 hybridized, so this is also aromatic. In the third case, in the third option, we are not going to find out alternate double bond, single bond, double bond, single bond, single bond. Both single bond came, and single bond means sp3 hybridized, so it will not show planarity, and it will not satisfy Huckel's rule. So because of that, option 3 is not aromatic. This we can find aromatic. It has 4 pi electrons according to Huckel's rule, and it can satisfy alternate single bond, double bond, single bond, lone pair, single bond, double bond, that it can follow. So option 3 is the right answer. Option 3 is not an aromatic compound. In the next question, primary aliphatic amines react with HNO2 to give unstable. Yes, children, primary aliphatic amines like methanamine on reacting with HNO2, it gives unstable diazonium salt. Statement 1 is right. Second statement, primary aromatic amines react with HNO2 to produce diazonium salt. Yes. And which are stable at 300 Kelvin. No, children, in diazotization reaction we studied, this reaction will happen between 0 to 5 degrees Celsius, not 300 Kelvin. So statement 2 is wrong. So in that case, option 2 is right, statement 1 is correct, but statement 2 is incorrect. You can see the reaction, diazotization reaction for primary aromatic amines takes place at 0 to 5 degrees Celsius. 71 question. The Kjeldahl method for the estimation of nitrogen can be used to estimate amount of nitrogen in which of the following compound. So there are 4 options given. Among the 4 options where we can find the estimation of nitrogen by Kjeldahl methods, we need to find out. So children, one thing you should remember, in the nitro compound, in the azo compounds, and nitrogen present inside the ring, for example pyridine, this is pyridine. In these case we cannot estimate nitrogen by Kjeldahl method because they do not react with ammonium sulfate. These nitrogens cannot react with ammonium sulfate. So these 3 cannot estimate. Aniline can be estimated by Kjeldahl methods. So you can see here explanation part. So aniline or benzamine can able to estimate by Kjeldahl method. Let us move to the next question. Which of the following pressure volume curve represent maximum work done? So if you want to find out maximum work done, what you need to find out is under the curve. So whatever the area is there that represents magnitude of the work. Magnitude of the work can be observed under the curve. So among the 4 graphs, in graph 1, we can find out more magnitude of the work under the curve. So option 1 is right answer for this question, because in PV graph area under the curve represents magnitude of the work. So in graph 1 we can find maximum area. That's why it has more magnitude of the work. Let us go to the next question. The pH of the solution containing 50 ml of each of 0.1 molar sodium acetate and 0.01 molar of acetic acid is. We need to find out the pH for this case. So to find out the pH, we have a formula. pH is equal to pKa plus log of salt by acid. So pKa value is given 4.57 of acetic acid plus log of salt, sodium acetate concentration 0.1 and acetic acid concentration 0.01. So when you divide this, you will get log 10, and log 10 value is 1. When you add this with 4.57, you will get answer 5.57. So answer is 5.57 is the pH of this case. So acetic acid is a weak acid and sodium acetate is a weak salt of weak acid and strong base. So the both can form acidic buffer. So when you calculate, you will get pH 5.57. So in the next question, which among the following is an incorrect statement? So C2 molecule has 4 electrons in its 2 degenerate pi molecular orbital. C2 molecules means carbon molecules. It will be having 6 2s are 12 electrons. When we write the electronic configuration, it will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Then remaining 4 electrons we should write in pi orbital. Pi 2px2 equals pi 2p y2. So these are the degenerate pi orbitals. It has 4 electrons. So this first statement is correct for carbon molecule. In the second statement, hydrogen ion H2 plus ion has 1 electron. Of course, in hydrogen molecule there are 2 electrons. So after losing one electron, it will form H2 plus. So this is also correct statement. Both the statements are correct. Let us go to the third statement. O2 plus O2 plus ion. O2 plus ion means oxygen molecule has 16 electrons. 8 to the 16. Atomic number of oxygen atom is 8. 8 to the 16. Plus means remove 1 electron. It will be 15. So when you write the electronic configuration of 15 electron, you can find that in O2 plus you can find 1 unpaired electron. So when 1 unpaired electron is present, that will be paramagnetic, not diamagnetic. So that's why option 3 is incorrect statement, that O2 plus has diatomic. In the next question, among the following, which one will have maximum lone pair electron repulsion? Maximum lone pair electron repulsion comes where there are more lone pairs. Wherever you will find more lone pairs, in whichever the compound you will find more lone pairs, there you can find more repulsions. Let us see one by one. So first we have IF5. In IF5, you can find iodine surrounded by 5 fluorine atoms, and it will be having 1 lone pair. So IF5 has only 1 lone pair. It has 1 lone pair. So it will be having less lone pair repulsion. Only 1 lone pair means repulsion will not possible. Let us see in SF4. In SF4 also we can find 1 lone pair only. Let us see in ClF3. In ClF3 we can find 2 lone pair. In ClF3 we can find 2 lone pairs. So there also we can find less repulsion. Whereas in XeF2, because of the presence of 3 lone pairs, in XeF2 we can find more more lone pair repulsion. Identify the incorrect statement from the following. So first statement, the oxidation number of potassium in KO2. Children, KO2 is a superoxide. It is a superoxide. In superoxide, oxygen oxidation state is -12 and potassium will be +1. So not +4. In KO2, potassium oxidation state is oxidation number is +1. So that's why this is the incorrect statement. Gadolinium is one of the F block elements with atomic number 64. Remember, so gadolinium has low value of third ionization enthalpy. Because of high exchange enthalpy. You can see as its atomic number is 64 F block elements, its electronic configuration xenon 6s2 4f7 5d1. So after losing 5d electron, 4f has maximum exchange energy. So GD has low value of third ionization enthalpy. This is very easy question. The incorrect statement regarding enzyme. The enzymes are polysaccharides. So this is the incorrect statement because enzymes are protein in nature. In the next question, we need to find out the incorrect statement. All the 5 4d orbitals have shapes similar to 3d. Yes, 4d, 3d orbitals have same shape. This is correct statement. In an atom, all the 5 3d orbitals have equal energy in the free state. In the free state, all the 5 3d orbitals have same energy. This is also correct statement. The shape of the 5 dxy, dyz and dxz orbitals are similar to that of dx square minus y square and dz square. This is the incorrect statement because all the 5d orbitals have different shapes. So option 3 is incorrect statement. Let us batch list 1 with the list 2. Lithium can be used in electrochemical cell, and sodium can be used as a coolant in fast breeder reactor, and potassium hydroxide is used to absorb carbon dioxide, and cesium is used in photoelectric effect. So in this case, option 3 is the right answer for this question. In the next question, statement 1, the acidic strength of monosubstituted nitrophenol is higher than that of phenol because of electron withdrawing group. Yes, nitro group is an electron withdrawing group. So in monosubstituted nitrophenols, they have higher acidic strength. Statement 1 is correct. Let us go to the statement 2. Orthonitrophenol, metanitrophenol and paranitrophenol will have same acidic strength. No. They cannot have same acidic strength because para has more acidic strength than ortho, then meta. So as you can see here, so statement 2 is right answer for this question. Statement 1 is correct and statement 2 is incorrect. Let us see the order of acidic strength. So you can find paranitrophenol is having more acidic strength compared to ortho and meta, and phenol having low acidic strength. The pollution due to oxides of sulfur gets enhanced due to the presence of one is particulate matter, ozone and hydrogen peroxide. So let us see. So option 1 is the right answer. The presence of particulate matter in the polluted air catalyzes the oxidation of sulfur dioxide to sulfur trioxide, and even in the presence of ozone and hydrogen peroxide also it is responsible for pollution by forming sulfuric acid. Let us find out the correct IUPAC name of the following. So in this case, first carbon, second, third, fourth, fifth and sixth. Total there are 6 carbon. So hexane is the root word. At first carbon, bromo, then third carbon, hydroxy group, alcoholic group, fourth carbon, methyl group, and fifth carbon chloro group. So alphabetically we can say 1 bromo, 5 chloro, 4 methyl hexane, 3 all. So option 4 is the right answer for this question. 1 bromo, 5 chloro, 4 methyl hexane, 3 all. Let us go to the first statement. In Lucas test, primary, secondary and tertiary alcohol can be distinguished on the basis of the reactivity with Lucas reagent, concentrated HCl and zinc chloride. So this statement is right because Lucas reagent is used to differentiate primary, secondary and tertiary alcohol. Let us go to the second statement. Second statement says primary alcohol is more reactive. No. Primary alcohol will react with Lucas reagent only after heating. So statement 2 is wrong. So accordingly, statement 1 is correct and statement 2 is incorrect. Next question from D and F block elements. In neutral and faintly alkaline medium, potassium permanganate oxidizes iodide into iodate. The change in the oxidation state of manganese. So in potassium permanganate, the oxidation state of manganese is +7 and in MnO2 oxidation state of manganese is +4. So option 4 is right answer for this question. Let us go to the next question from chemical kinetics. For the first order reaction, A gives rise to product. Initial concentration of A is 0.5. It will become 0.01 in 5 minutes. We need to find out rate constant K. So to find out the rate constant K for first order reaction, we have a formula. Rate constant K is equal to 2.303 divided by T. Time here is how much? 5 minutes into log of initial concentration. Initial concentration 0.1. It will convert to final concentration 0.001. When you divide, you will get log 100. And log 100 value how much? 2. So when you multiply this 2 with this value, you will get 0.212. So option 1 is the right answer for this question. Let us move to the next question. Compound X on reaction with ozone. It's a ozonolysis reaction followed by zinc. On hydrolysis gives formaldehyde and 2-methyl propanol. We need to find out X among these 4 options. So the products we are getting, one is formaldehyde, 1 carbon aldehyde, and another one is 2-methyl propanol. So on treating with ozone followed by hydrolysis with this compound, 3-methyl butene will get these 2 products. So 2-methyl but 1-ene is the right answer for this question. So 2-methyl butene on reacting with ozone, it gives formaldehyde and 2-methyl propanol. Next question from coordination compound, the order of energy absorbed which is responsible for the color. So order of energy absorbed depends on the number of strong ligand. So as the number of strong ligand increases, energy absorption also increases. So as you can see in first coordination compound, there are 2 here. En is a strong ligand. Ethane 1,2 diamine is a strong ligand. You can find in the A 2 strong ligands. In B you can find only 1 strong ligand. In C you can find 3 stronger ligands. So more energy you can find in C, then in A, then in B. So in that case, so we can find option 2 is the right answer for this question. Option 2 is the right answer. So as the number of strong ligand increases, splitting also increases. So maximum we can find wherever you can find more strong ligands. Next question from electrochemistry, find the EMF of the cell in which following the reaction takes place. So you can see here nickel converts to nickel ion, so N value is 2, number of electron is 2, E0 value has been given, product side ion is nickel ion and reactant side ion is silver ion. So we have to use here Nernst equation. So the formula is E cell is equal to E0 cell minus 0.059 divided by N log of concentration of product divided by concentration of reactant. So E0 value is given, that is 10.5 minus 0.059 divided by N. N means number of electron, that is 2. And log of product concentration, product is nickel ion, its concentration is 0.001 molar divided by reactant concentration, reactant is silver ion, there are 2 silver ions, so we will get 0.001 whole square. So when you divide this, you will get log 10 to the power of 3. Log 10 to the power of 3 value will be 3 only. So when you calculate, you will get 10.4 volt is an answer, but in the option there is no correct value has been given. So you can see here by substituting the values, E0 value has been given 10.5, number of electron is 2, concentration of Ni2 plus is 10 to the power of minus 3, that is 0.001, and concentration of silver ion is 0.001, that is 2 times. When you calculate, you will get log 10 to the power of 3, log 10 to the power of 3 value is 3. After calculating, you will get 10.4 volts. Here is the last question, the product formed by the following reaction. We have a cyanide on treating with lithium aluminum hydride. So cyanide group undergo reduction to produce CH2NH2, means amine. It will convert to amine. This part converts to amine, followed by treating with NaNO2 and HCl. It is a diazotization reaction. So because of diazotization reaction, we will get here diazonium salt, that is CH2N2Cl, benzene diazonium salt we will get. So this on hydrolysis gives one primary alcohol, benzyl alcohol, CH2OH. So this is the product. Let us find out the answer, option. So option 3 is the right answer. As you can see in the reaction, first it undergo reduction to form one of the primary amine, then benzene diazonium, phenyl benzyl diazonium salt, then followed by hydrolysis to give one of the primary alcohol. I hope it is going to be very helpful for you children. Thank you.